Hey everyone, welcome back to our channel. Today, we're going to solve this circuit using Norton's theorem. To determine the current flowing through the load RL using Norton's theorem, we have to find the values of Rn and In. Rn represents Norton's equivalent resistance, calculated by 1. Opening current sources. 2. Short the voltage sources in the circuit. As for In, it stands for Norton's equivalent current or short circuit current, determined by shorting the load RL. So meaning, In is the current flowing here in the circuit once the RL is shorted. It is also called ISC or short circuit current. Let's start by finding Rn. Remove the load RL, marking points A and B on the circuit. Since there's only a voltage source in the circuit, we simply short it to find the equivalent resistance between points A and B. To calculate that, R1 and R2 in parallel. And the equivalent resistance will be added to R3. And that's it, that is the Rn. Which is equal to 1 times 2 all over 1 plus 2 plus R3, which is 3. That will result in 3.67 ohms. And for the In, we just have to short the load RL to find the current flowing at shorted RL. To solve that, first find the total current flowing to the circuit, using the current divider formula to find the current flowing to R3, which is the same as the In or short circuit current. I total is equal to E divided by R1 plus R2 times R3 all over R2 plus R3. Substituting the values, 100 divided by 1 plus 2 times 3 all over 2 plus 3, which is equal to 45.45 amperes. Using the current divider formula. Then In is equal to I total times R2 divided by R2 plus R3. So In is equal to 45.45 times 2 all over 2 plus 3, which will result in 18.18 amperes. Then to find the current flowing to the circuit, we have to draw it like this. As you can see, it can be solved by simple current divider formula. IL is equal to In multiplied to Rn all over Rn plus RL. So 18.18 amperes times 3.67 all over 3.67 plus 10, which is equal to 4.88 amperes. So the load current is 4.88 amperes. So that's it. That's how we solve a circuit using Norton's theorem. Thanks for watching. If you liked learning about electrical circuits and Norton's theorem, give us a thumbs up, share the video and hit subscribe. Drop any questions or topics you want us to talk about in the comments. See you next time, and keep having fun with your discoveries.